you've read this section in your chapter already, you know that a rational function is a quotient of polynomial functions. So an example of a function that would be a rational function would be something like this. If we have the polynomial x squared minus 25 over the polynomial x minus 5, then the entire function f of x there is a rational function. We recognize that with thinking about the domain of this function, we need the denominator, x minus 5, to never be allowed to be equal to 0. So our domain is going to be all real numbers except x equal 5. If we wanted to write that in interval notation, it would look like this. Now the simplest rational function is the reciprocal function. The equation f of x equals 1 over x. It's called the reciprocal function because that's the reciprocal of x. We know that the domain would not include x equals 0. And if we think about graphing this function, let me grab my graph. I think that one will work. All right, let's just plot some points. If you find f of 1, you'll have 1 over 1, so that's the ordered pair 1, 1. So I'm going to plot that point. If we plug in 2, we'll have 1 over 2, so that's going to be the point 2, 1/2. If I plug in 3, I'll have 1 over 3, so that's the point 3, 1/3. And of course, if you plug in 4, you're going to have 1/4. If you plug in 5, you're going to have 1/5. What's going to happen as our x values get bigger and bigger and bigger, the y values are getting smaller, getting closer to 0. Now, it's also important for us to talk about what's happening as our x values get. We know x can't be equal to 0, but what happens if it gets close to 0? So I'm going to find f of 1/2. I'd have 1 over 1/2, or 2. The reciprocal of 1/2 is 2, so that's the ordered pair 1/2, 2. If I plugged in 1/4, I would have 1 over 1/4, or the reciprocal of 1/4, or 4. So what happens as our x values get closer to 0, our y values are getting bigger and bigger and bigger. So we could actually sketch this curve. Okay, and it shouldn't actually touch the x-axis there, but it should come down very, very close to the x-axis. And if you plot some points that are negative, you think about it, if I go back and I make all of these x's negative, so then I'll have -1, -1. Let's see, let me just finish making everything negative, 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 negative. Alright, so we would have the point -1, -1, -2, -1/2, -3, -1/3, and so on. -1/2, -2, -1/4, -4. So we would have a part of the curve that gets very, very close to the y-axis as x gets closer to 0, and gets very, very close to the x-axis as x approaches negative infinity, as x gets smaller and smaller and smaller. So let's talk about what we're looking at here. As x gets larger, so as x approaches infinity, that's a way of saying that it's getting larger, our values for f of x are getting closer to 0. as x approaches negative infinity, we have the same thing. Our values of x, they are negative numbers, but they are getting closer and closer and closer to a y value of 0. So when we've got this situation, as the x values get very, very large and very, very small, and the y values get closer and closer and closer to a constant value, we would say that that y value is a horizontal asymptote. So if I'm going back to my curve and I wanted to draw in that asymptote line, we typically draw them with as dashed lines. So let me do that. And I'll make it a different color so you can definitely notice it. And then I'll move it to exactly where it belongs. Okay, so the x-axis, or the line y equals 0, is a horizontal asymptote for this curve. Now let's talk about what's happening, as x comes in closer and closer to 0, our y values are getting bigger and bigger and bigger. Now we're approaching 0 from the right side here, from the positive side. So the way that we can talk about that is we can say that as x approaches 0 from the right, a little plus where an exponent would be means from the right, our function values are approaching infinity. And if you look at what happens as x gets closer to 0 from the left side or negative side, our function values are going down, so they're approaching negative infinity. So as x approaches 0 from the left, f of x approaches negative infinity. And when you have these situations, then at that value of x equals 0, is a vertical asymptote.